Alright, so day 4. Day 4, we're going to talk a lot about algebraic manipulation to get to the answer for the limits, okay? This is a big part of how you're going to be able to do this without a calculator on the test, okay? Alright, here we go. So there's a lot that we're going to recall back from Algebra 2, Pre-Cal, whatever it is. And here are 2 examples immediately. There is such a thing of sum and a difference, both of cubes. Okay? We know there's a difference of squares, but there's not a sum of squares. Sum of squares include imaginary i's, and we're not working with that, okay? But there is sum and difference of cubes. The acronym is SOAP. It's the same, opposite, always positive. The way you would see a cubed plus b cubed would be the following. The first one is a binomial, the second one is a trinomial. I'm going to look at my first term and I'm going to cube root that to get a. I'm going to cube root my second term to get b. And right here, the same sign is going to go right here. That's where your acronym comes into play. Okay? So again, that first term was cube rooted to get that. This was cube rooted to get this. Notice the color coordinating. So the same sign, and then the opposite sign, and then the always positive sign. So the opposite sign of this right here is going to be a subtraction and always positive. Okay? Now, how do I get the 3 pieces to this trinomial? The first one is a squared. You're just going to square this term. The last one is the square of this term. And don't pay any attention to this plus. Don't pay any attention to any signs. SOAP will take care of the signs. But what is this times this? It's going to be AB, and I heard it. It's not going to be 2AB. That's fold method, and that's with that multiplicity of 2. This is not the 2AB, so please don't confuse it with that. This is strictly whatever this is times that, that's what's going to go as your middle term. Okay, so there we go. So if I did the same with the difference of cubes, I know it's a binomial, trinomial. It's the same sign, so I'm going to put a negative or a subtraction. It's the opposite and always positive. Okay? If I cube root this, I get A. Cube root this, I get B. From here, I would square this first term to get this, square this last term to get this, and then just multiply these together to get that. To me, it's easier to memorize processes than just remote equations, okay? Remote memorization is difficult, okay? I want you to kind of remember processes. Any questions before I keep going? Yeah.
Can you move further?
Yeah. All right, so now we're going to factor the top. Okay, before I factor, I went a little bit too fast. My limit is evaluating at 3. Step 1 we learned last time is always direct substitution. So if I plug in a 3 into this equation, I would get a 0 over 0. The fact that the bottom is a 0, otherwise making it undefined, we know that we're going to have to try what? Algebraic manipulation. We're going to have to do some kind of algebra, and our goal is to cancel x minus 3 from the denominator. That's our goal. Okay? Here we go. So factor in the top, I'll get x minus 3. So it's the same, opposite, always positive. Okay? The first one is x squared. The last one is 3 squared, which is 9. And now just multiply these together to get 3x. I just factored that. Now the bottom has x minus 3. And you should see it already. This is a cancellation form of what? 1. here? What exists here that allows me to cancel right there? Multiplication. You cancel between multiplication, not between additions and subtractions. Okay? On a graph, what does this represent? A removable discontinuity, a hole in the graph. Okay? So what's going to be graphed is a quadratic. This x squared plus 3x plus 9, it's a quadratic. It's a parabola of some kind with a hole at 3. Okay? That's what's visually happening. Now, you just canceled the piece that otherwise would have made this originally undefined. What are you going to do next? Plug in. Plug in your limit. So we're going to plug this into the remnants that are left over. And anyone, what do I get? 27. Now I want you to box it like this. Now I know I said don't box on the test, okay? That's okay. Please don't box on the test. But I'm saying more so for your notes, okay? So that when you go through, you know what the answers are. Any questions? Now, real quick. Do y'all remember this? Let's see if you know what I'm doing. Synthetic substitution. Listen. Synthetic substitution is different than synthetic division of why you do it. Synthetic division, you're trying to see, is this x equals 3 a factor of this entire polynomial? That's synthetic division. What I'm doing right now is just synthetic substitution. And some of you are going to see this. I hope very few of you. And you're going to say, that's way too much work just to get 27. But when we do fractions, I promise you, you're going to wish that you had built this skill up. So, all I'm doing is throwing in a 3. So I copy, I multiply, add. And I multiply, add. There's your answer. Synthetic substitution will get you your y value output. Some of you are thinking to yourself, it's easier, Mr. Gomez, just to plug that in. I know it is for this example. But for other ones that involve fractions, please develop this skill because you will need it for fractions. All right. Questions? Okay. So, calculus likes to pretend it's difficult by throwing all these symbols at you. This just means delta x. It's just as arbitrary as x, just as arbitrary as y or f. Doesn't matter. So think of this as the input value that you're actually going to input into the limit. Think of it the way we thought of 3 up here, or x. You see what I'm saying? Here we go. If I plugged in 0 right here, right now, it would be 0 over 0. Okay? So we have to do some algebraic manipulations. Here we go. Distributing the top, I get 3x plus 3 delta x minus the 3x that was already there and the delta x on the bottom. Guys, you will hear me say this all year. Multiplication cancel to forms of what? 1. What do addition and subtraction cancel to forms of? 0. Look at this right here. This is a form of canceling to 0. In the numerators, they cancel to 0. Numerator and denominator, they cancel to forms of 1. Okay, y'all see that? Alright, so I'm left with 3 delta x over delta x as delta x is approaching 0. What do we always want to do before we throw in that limit value? Simplify. Simplify your life before moving forward. Simplify these equations before you continue forward. Can I cancel these?
Yes.
Yes, because it's a form of 1 and it's multiplication. So I'm left with the limit of 3 as delta x approaches 0. Anyone, what's my answer going to be? 3. Because I do not see any more delta x's left over that I can plug 0 into. So it's just going to be 3. All right, let's keep going. They try again. They want to see if they can confuse you with what you see with all these different variables and whatnot. Okay? So we have f of x plus delta x minus f of x all over delta x, and this is our function. This is a big part of what calculus is all about. Just this little equation right here. Okay. This is my input that I'm going to throw into that function. Okay? So this is my function, and I'm going to throw this into right here. Okay? So what I'm building right now is f of x plus delta x is actually equal to throwing that in right there. What I just did, all of this right here, boxed in blue, all of that is that. And back when I was your age, it took me like 10 problems to finally figure that out. Okay? All it is you're just putting in an input. That's all you're doing. Don't make it more difficult for yourself. Okay? Now, so let's write that over here. 2x plus delta x minus 5. And it's going to be subtracting something over delta x. Notice my color coordinating to help you see it. Okay? What am I going to put? So all of this was that blue box that we just found. What's going to end up being written here? 2x minus 5, the whole f of x. Okay? Now, I'm going to write 2x minus 5, but the way that I have it written right now, I'm making the number 2 mistake most common in calculus. I need parentheses. I need parentheses, okay? Because it's going to make that negative 5 turn into a positive 5. Okay, so now, let's start simplifying. We have 2x plus 2 delta x minus 5. Help me out. What do I continue to write? Minus 2x plus 5. All over delta x. Can I plug in now? Should I plug in now? No, because I haven't done what? Not simplify, but I haven't canceled the part that made the original function undefined. My goal is to eventually be able to cancel out this. Yeah?
Why is that a plus 5 note in the top right?
Because this parenthesis says a negative distributed will make it a positive. That is a huge negative mistake. Remember, negatives are the number 1 mistake in calculus. Okay? Alright. Remember, all we're doing right now is pretty much just algebra 2, but with a lot of different variables. Okay. I'm going to keep repeating it. What will these cancel to? 0. What will these cancel to? 0. So guys, it looks ugly. It looks worse than what it actually is. If you did the math correct, a lot of things will cancel. So what I have left over is what in the numerator? 2 delta x. Remember, I want you to write this limit every single line, please. Will I deduct on your quiz or test if you're not doing it every single line? I will. So please write it every single line until you finally get the answer. what should I do next? Cancel out to a form of 1. So what's left over is just the limit as delta x approaches 0 of 2, which anyone, what would that be? 2. There's your answer. Okay? Not too bad, right? Alright, so let's do more algebraic manipulation, because some of these do change. Let's go, yeah, we'll go with sine. What I want you to do is I want you to put this into your calculator, okay? So with me, what we're going to do is we're going to put sine of x over x, and we're going to see what we get. Okay, so let me go ahead and pull my calculator up. Alright, so I just put this into my calculator, and it gave me a function that looks something like the following. And right here is 1. We're going to look at the algebra here soon, but I want to look at the graph for now. What would that answer be? What do you think? If you approach 0 on this graph, what would the limit be? It would be 1. So the first thing that we're going to memorize is that this will be 1. Okay? So now let's go to, and again, we got that from the graph here. If we approached x is equal to 0, which is right here, the limit would equal 1. So now let's go back and let's put our other one of 1 minus cosine of x over x. Okay? So 1 minus cosine of x over x would give me, press tab, control divide, 1 minus cosine of x over x, and I get this red graph. Okay, so that one's a little bit different. And guys, if I approach 0 on that red graph, what would I get? I would get 0. So there's our second one that we're going to memorize. We'll see the algebra soon. But for now, we're going to memorize that the limit as x approaches 0 of 1 minus cosine of x over x is equal to 0. And yes, if you wanted to draw a nice, pretty sketch on that, you can. Something like this, so on and so forth. Alright, so with that being said, any questions before keep going? Alright, so other ones that I want to make sure that you're good to go on. So these are two important ones. Let's move on to these. What do you think sine of theta over theta, if theta approaches 0, would be? It would be 1 as well. Because it could be smiley face. As long as that smiley face is there, but also as long as you're approaching 0. Guys, if you're approaching infinity, it's not 1. Okay? If you're approaching 3, it's not 1. It only works if you approach what? 0. And what would this be? 0. Here comes the algebraic manipulation. Okay? So this tends to get people on the test. The first test that you'll have, this what we're about to do tends to get people. And the reason why it gets people is because they don't understand the variable of the smiley face that I just did just now. Okay? Here we go. If I plugged in 0 here and here, what do you see? Actually, let's go to Delta Math. We are done. I will record the rest next time.